Today, we're still on the basic techniques of integration, specifically on the substitution method. But this time, we're giving another example as an application of the substitution method because in the previous discussion, we only gave one example. So as a continuation, we have example 2. Find the indefinite integral that is given by the integral of x times the square root of 2x plus 1 dx. Now, we have to take note that the integrand here, we have product of two functions, x and this square root of 2x plus 1. Now, we recall that a substitution method can be used if you are given a product of two functions where one function is a composite function that is multiplied to the derivative of the innermost function. So we have to choose our u wisely. So for example, we let our u to be this function. So we have u is equal to the square root of 2x plus 1. And we have to take note that this is equivalent to this expression, which is equal to the quantity 2x plus 1 raised to 1/2. Okay? Now after this, we need to find the derivative of u with respect to x. Now here, it's easier to use this expression because we can use the power rule to find the derivative of u with respect to x. So using power rule, we use the exponent 1/2. We multiply 1/2 to this expression, to x plus 1. Then 1/2 minus 1 is equal to negative 1/2. So the exponent becomes negative 1/2 times the derivative of the innermost function. The derivative of 2x plus 1 is 2 dx. Okay? Now, simplifying the whole expression, we have 1/2 here and we have 2, so this will be cancelled out. So the simplified form is equal to du is equal to 1 over square root of 2x plus 1, because this expression here is just equal to the square root of 2x plus 1. But then, since the exponent is negative 1/2, so this expression is found in the denominator. So this is 1 over square root of 2x plus 1 dx. Now, what's more interesting here is we found out that this expression is just our u. So in other words, we have du is equal to 1 over u dx. Now, by manipulation, so we come up with u du is equal to dx because this is our u, right? So u multiplied to du, so we have u du, which is equal to dx. So we have to take note that our dx, this dx here is just equal to u du. Okay? So moving on, we go back to our u, which is equal to the square root of 2x plus 1. Now, so we have our u and we have our dx. So we have our u and we have our dx. But we still have x. So what are we going to do? So all we have to do is, from our u that we have, we can find x, which is in terms of u. How? We square this both sides, so we have u squared, and square root of 2x plus 1 becomes 2x plus 1 because we square this one. So this radical symbol will be cancelled. So we have 2x plus 1. So what we after here is to find our x in terms of u. So we have, by manipulation, we have x, which is equal to u squared minus 1 over 2 because this will be transposed to in this side. So we have negative 2x and u squared. This becomes negative u squared plus 1 multiplying by the negative. So we have x is equal to u squared minus 1 over 2 because we divide this one by 2. So our x is equal to u squared minus 1 over 2. So we have to take note that we were able to write x in terms of u. So, by substitution, our original problem is integral of x times the square root of 2x plus 1 dx. And since we have written that our x is equal to this, so by substitution, so x becomes this one, And since we know that this is our u, so we write u, and our dx is u du. Okay, so if we are going to look at this one, we have written an integrand which is in terms of u already. So simplifying this one, we have, since this over 2, this means that we multiply 1/2 to this expression. And since 1/2 is constant, so we write it here. So we have 1/2 times the the integral of u squared minus 1 times u du. So simplifying, since u times u is equal to u squared, so this one becomes this expression. So moving on, we have this. Now take note that the integral of this whole expression, so this becomes u squared times u squared is u raised to 4, right? Then u squared times -1, we have minus u squared. So in other words, by expanding this expression, we have integral of u raised to 4 minus u squared. Now, getting the integral of u raised to 4 minus u squared, we have u raised to 5 over 5 minus u raised to 3 over 3, okay, plus c, right? Because we have plus c sub 1 here, plus c sub 2 here. But since c1 and c2 are constant, so we can write big C to represent all the constants in each term. So this is the antiderivative of this whole expression. So we have u raised to 5, okay? 2 times 5 is equal to 10 minus u raised to 3 over 2 times 3 is equal to 6, right? So we have, in terms of u raised to 5 over 10 minus u raised to 3 over 6. But our problem, we have to remember that in terms of x. So all we have to do is to substitute our u, which is in terms of x, in this u. Since our u is square root of 2x plus 1, or 2x plus 1 raised to 1/2. So by substituting this to our u, so 1/2 times 5, this becomes 5 over 2. That's why by substitution, this is equal to 1 over 10 times the quantity of 2x plus 1 raised to 5 over 2. Okay, where did we get this 5 over 2? Because the exponent of our u is 1/2, then multiply to 5. And we have 1 over 6 times the quantity of 2x plus 1 raised to 3 over 2 plus c. So this is our indefinite integral of this problem. Okay? So example 3, find the indefinite integral of this problem. So again, we still choose our u. What would be our u? So in this example, we choose our u to be this one, to be the expression in the denominator. So this is our u, which is equal to the square root of x minus 3. And again, this is equal to quantity of x minus 3 raised to 1/2. Then we have to take note that by finding our x, we have what? Squaring both sides, we square this one, so we have u squared is equal to x minus 3. But we still have to find x in terms of u. So we have, this implies by squaring both sides, we have x is equal to u squared plus 3. So in other words, we have our u, this one, and our x, which is in terms of u, which is u squared plus 3. So next is to find the derivative of this. The derivative of this is using power rule. This is equal to 1/2 times x minus 3 raised to 1/2 times the innermost, or the derivative of the innermost function, which is equal to 1 dx. So we have this expression is just equal to 1 over square root of x minus 3, right? But since we still have 1 half, so the whole expression becomes 1 over 2 times square root of x minus 3. Now, what is this? This is just equal to our u. So, therefore, we have 2 times u. You multiply this 2u to du, so we have 2u du is equal to 2x. So in other words, our dx in terms of u is 2u du, and we have our u, which is this one. This is our u, and our x, which is u squared plus 3. Okay? So by substitution, the integral of x over square root of x minus 3 dx is equal to what? X, we have written x as u squared plus 3, so we substitute it here. And square root of x minus 3 is our u. And our dx, we have written that this is equal to 2u du. So we have to look at this one, that the integrand is already in terms of u. We have to take note that we have the denominator u here and we have u here, so this will be cancelled out. So, and we have also constant 2 here, so we need to isolate 2, or we write 2 outside the integral symbol to simplify the whole expression, because this will be cancelled. So what is left is the integral of u squared plus 3 du. Now, it's easier to solve the integral of this. So how to solve the integral? Now, the integral of each term, let's say the integral of u squared is u cubed over 3 plus the integral of 3 du is 3u. Then we need to put c, okay, to represent all the constants. Then we multiply the constant 2 um, to this expression. So simplifying that one, we have 2u cubed over 3 plus 2 times 3u is 6u plus c. But again, we need to convert we need to use our original u, which is in terms of x. Now, our u is this, so we have our u is square root of x minus 3, then that means raised to 1 half, so multiply by 3, so this becomes 3 over 2. So our answer is 2 over 3 times the square root, by the way, quantity of x minus 3 raised to 3 over 2 plus 6 times the quantity of x minus 3 raised to 1 half plus c. So that is the answer of the indefinite, or that is our indefinite integral of this problem. Okay, so hope you like this video and hope you learned from the two examples that we have. And don't forget to share the learning that you've got from this video. Thank you so much and God bless.